So the way we're going to change the problem, you always analyze these problems by discrete choice, all the discrete choice problems. But if you actually look back in economics a little while, historically, the same problem was analyzed a long time ago, and it was called revealed preference. Okay? So this started with a famous article by Samuelson, and Hal Varian had a bunch of articles on it. And this is going to take off from that. Okay, this is the starting point of that. The difference between what I'm going to do today and what was done, with starting with Samuelson, is they never worried about putting errors in it, disturbances in the thing, because they weren't really doing empirical work at the level that we do today. They didn't have the data sets we have today. They didn't have computers that we have today. So what I'm going to do is put errors in the revealed preference thing, and then show how you estimate given real preference, just revealed preference type arguments. Okay? So it's going to matter the properties of the errors, just like it does in discrete choice. Okay? So it's going to be, we're going to have to pay attention to that. So what you work with now is not really a model, and there is a model, but it isn't, in a sense, it's going to be much more weakly specified than the models you're used to in standard discrete choice. The way it's going to go is the following. It's going to say, I know what the individual chose, and I know some other option that the individual knew that he could have chosen, or it could have chosen, okay, rather than the one it did in fact choose. Okay. At the very least, what I'm going to assume is its expected utility or expected return from the choice the individual made is greater than the expected return from the choice the individual didn't make. So that's revealed preference, okay? And that's all I'm doing, okay? The two things about it, I'm going to have a parametrized model for the utility, okay? So that difference will be positive, okay, for some values of the parameter vector, and not positive for other values of the parameter vector. At the true value of the parameter vector, we think it's positive. Okay, and that's going to be the information content used in estimation. Okay? The problem that's going to arise, and this is what got the econometricians going, which sometimes I'm a fellow traveler, is that if one value of a parameter satisfies an inequality, typically values close to it will also satisfy the inequality. It's an inequality, not an equality. Okay? So we get estimators of sets instead of the set, and the property of the set is we know the true parameter, at least in the limit. The property of the set is we know the true parameter is in that set, and that's all we know. Okay? So it's going to be a weaker form of identification. Formally, it's called partial identification. It's been in the literature, in the econometric literature, actually, for quite a bit. The first time I ever saw it was in a paper by Marshak and Andrews on production functions, a very famous paper. The first paper on simultaneous equations bias was really Marshak and Andrews on production functions. But again, it's only recently has been brought to sort of starting to be used, and the econometrics worked out, okay, in detail. Okay, I'm going to start with an example which is due to a student of mine who's either smart enough or stupid enough, depending on how you look at it, to go join a hedge fund afterwards and make a lot of money. Okay, so his name's Michael Katz, and it was in his thesis. Okay, this was his thesis. Okay, so he takes what is a real classic problem, both in I/O, by the way, and in public finance. I start with this example because the example illustrates very well exactly what's going on in this stuff, okay, and without doing anything formal. So I could start with, for example, this paper by Pakes, Poterba, and Ishii. But then you get to these conditions which are right for econometrica, but not the right way to explain it to people. Okay, so I'm going to do it this way, okay? So we're going to estimate the cost shoppers assign to going to a supermarket. Okay, to driving to the drive time cost. Okay, it's a problem of big importance for public finance also, and you probably don't know this, but the third biggest expenditure category of people is food. Well, it makes sense, right? There's housing. I don't know if automobiles is greater than food or not. Transportation might be better than food, but it's a big part of the economy. Maybe health. Maybe I've got this wrong. I probably have old data on that, but it's a big part of the economy. The other thing is it influences things like zoning laws. Zoning laws are